Okay, good evening. Welcome to
FamilyMath588.
FamilyMath588. So we're going to continue our little exploration with calculus today. And I'm going to ask you this question. So here's the x and y axis. And here's a graph of a function called y equals the absolute value of x. Have you ever heard of this function before?
No.
No? Have you?
Yes.
All right. What does absolute value of x do?
So absolute value just takes the number and sees how far the number is away from 0.
Okay.
So if the number is positive, it does nothing.
All right.
If the number is negative, it makes it positive
Okay. By doing what?
by just removing the negative sign.
Okay.
Yeah.
Or we could say that this function is x if x is greater than or equal to 0. And what is it if x is less than 0?
Minus x.
Minus x. Yeah, that's another way you can think of absolute value.
Okay.
And your brother's right. All it does is tell you how far away from 0 you are. So the absolute value of 3 is?
3.
The absolute value of minus 2 is?
2.
The absolute value of 0 is?
0.
The absolute value of 10 is?
10.
Yeah. You got it?
Yeah.
All right. So that's absolute value. What I want you to draw for me is what you think the derivative of absolute value is. I seem to be running out of markers. I'm not sure why. Let's see if this one works.
Well,
But first of all, what is the derivative?
So it's how steep this line is here.
Okay.
it's sort of odd on this one because where do you start here?
All right.
We can say we just start in the middle. And the derivative in the middle seems to be flat.
Okay.
And then, but the derivative, it just goes up at a constant rate.
Okay.
So it's gonna look quite a bit like this.
Well, what is the derivative?
So it's the slope of this function at some points.
Okay.
So,
So the derivative is
the slope.
the slope. Okay.
Well,
Here the slope would be negative though, so it would be down here.
so it would be negative 1.
Okay.
And up here the slope is positive 1.
All right.
So wouldn't that just be something that looks like this?
Interesting.
And then these points, this point is in it, but these 2 points are not.
Okay. What do you think about this drawing here?
Yeah, it looks pretty good. Looks like the derivative would look like.
All right. So explain to me then why you can you explain? Your brother drew this, so you explain why does the derivative of absolute value of x look like these two line segments that are not connected to each other?
For this side over here, the absolute value is just so it would just on this side just it's y equals x.
Mm-hmm.
So it would just be always the slope is always 1 on this side here.
Okay.
And then over here, it's basically y equals negative x, so that makes it the slope negative 1.
Yeah.
And then at the point 0, it's sort of hard to tell if the slope is x or if the slope's 1 or negative 1,
Mm-hmm.
because really close in either direction.
Yeah. What happens when you zoom in on this? If you were going to zoom in like super far, like Grant Sanderson does in his movie, let's say instead of this being minus 1 and plus 1, like maybe that's what I did here.
Mhm.
Like what if it was minus 0.00001 and plus 0.0001? Is that how many zeros? What if I zoomed in? What does absolute value look like if I zoom in? Does it flatten out?
No, it just stays constant.
Well, it definitely does not stay constant.
Well, it stays. The 2 lines stay the same. One is a slope of 1, one is a slope of -1.
It just
Okay.
looks like it is shrunk down.
And what if I keep zooming in?
it'll look the same.
Yeah, so it is a bit of a mystery. And, you know, years from now, when you actually take calculus for real, you'll learn how to deal with this situation.
Okay.
But for now, this is fine. So we have a function that I could draw without lifting my finger up, right? I could just draw that absolute value. And the strange thing about the derivative is I have to lift my finger up to draw it.
Yep.
That's a surprise.
Yep.
All right, so now we're going to go to the next part.
Alright.